This is video number 1 for sections 8.3 and 8.4, Basics of Adding and Subtracting Fractions. So in this lesson, we're still dealing with rational expressions. We've already multiplied and divided them, and now we're going to add and subtract them. And just as I did with multiplication and division, I'm going to start out by reminding you of some of the details of just a regular fraction addition problem. Okay, now you might be looking at this thinking, well, this is very, very easy. But if you can understand the fine details in working a problem like this, that will help you a lot when we get to the messier rational expressions. So in this problem, we're going to add the two fractions 5/6 plus 1/9. Now you might remember adding and subtracting fractions is a little more challenging than multiplying and dividing. With multiplying and dividing, you can just kind of plow in, start your work. You can't really do that here with adding. In fact, you can't add fractions unless the two numbers at the bottom, the two denominators, match. If they don't match, then you have to find what's called the lowest common denominator and change each fraction so that the denominators do match. Now, how do you find that lowest common denominator? Again, this is such an easy example that probably you can see in your head the smallest number that both 6 and 9 go into. That would be the number 18. But what if you couldn't easily see that in your head? Is there some method you can use? This is important. The method for obtaining that LCD is based on factors. Now, when you talk about factoring numbers, you're talking about the prime factorization. In other words, what prime numbers could I multiply to get 6? Of course, that would be 2 times 3. And what prime numbers could I multiply to get 9? Well, of course, that would be 3 times 3. I've replaced the 6 and the 9 with a factored version of those two numbers. The prime factors are like the building blocks of the numbers. And if you multiply certain of these building blocks together, you can come up with the lowest common denominator. The idea is you just need to make sure that each list is satisfied when you put those building blocks together. Now, what do I mean by that? Well, let me tell you a little story that may help you to understand what's going on. The story goes like this. A guy is sent to the grocery store by his wife to pick up some items. When he gets there, he reaches into his pocket and realizes, unfortunately, that he has two different lists. One list says, buy a loaf of bread, buy a gallon of milk. The other list says, buy 2 gallons of milk. He can't remember which one is the right list. He left his cell phone at home, so he can't get in touch with his wife. He just wants to get enough stuff at the store so he will be safe either way. What's he going to buy? Well, to satisfy the first list, he's for sure going to pick up a loaf of bread and a gallon of milk. But just in case the second list is going to be correct, he's going to pick up an extra gallon of milk, right, bringing it to 2 gallons, and that way he'll be safe either way. Would he buy 3 gallons of milk? Of course not, because none of the lists require 3 gallons. By buying a loaf of bread and 2 gallons of milk, he's safe either way. We'll go back over here to our fraction problem. That's the idea behind finding the LCD here. What do I have to take so that the first list is satisfied? Well, I better take a 2. The second list doesn't need any 2's. The 2 is like the loaf of bread. I better get a 2 just in case the first list is the right list. What about the 3's? Well, the first list needs 1 3. The second list needs 2 3's. That's like the gallons of milk. I better take 2 3's to be safe. That's plenty for the first list. I mean, the first list only needs 1 3. Great, I got that. But the second list requires 2 3's, so I need to take 2. If you multiply all this together, 2 times 3 is 6, times 3, there's your 18. Another way you can say this is just go by the pickiest list for each factor. Who's pickiest with the 2's? Well, this guy, so I'll take the 2 from that list. Who's pickiest with the 3's? Well, the second guy needs 2 3's, so I'll take the ones from that list. This idea of satisfying the lists is going to be very, very helpful when we get to the more complicated problems in the next video. Okay, back to our original problem then. So we wanted to add 5/6 plus 1/9. We can't do it right now. What we've realized is that we have to change these two fractions so that the denominators match, and we've decided that 18 is the denominator that we're going to use. How then do you make the change? Well, there's only one thing you're allowed to do with a fraction to keep it equivalent, and that is to either multiply or divide the top and bottom by the same number. I used to have a 6 down here. I would like it to be 18. Well, I can accomplish that by multiplying that 6 by 3. And if that's what I have to do on the bottom, I have to do the same thing on the top to stay equivalent. For the second fraction, I had a 9. I want it to be 18. I'm going to have to multiply by 2 to accomplish that, which I can totally do as long as I also do the same thing up top. Another way that you could think of how we obtained this 3 or this 2 is by thinking about the building blocks. Remember, 18 came from a 2, a 3, and a 3. Well, the first fraction already had a 2 and a 3. It was just missing that extra 3. The second fraction had the 2 3's. It was just missing the 2. So it makes sense why those were the missing pieces. Okay, now what? We're almost done. And it's interesting, there's very little left to be done, but sometimes people mess up right at this spot, especially when we start throwing all the x's in. I guess it's because of the multiply divide stuff, people's brains go toward that cross cancel idea. Maybe you're looking at this 2 and this 18 and seeing the common factors. That has nothing to do with adding fractions. That's only a multiply fractions issue. There is no cross canceling here. Common factors are irrelevant. You have to remember why you just did what you did. We made these denominators the same because we needed them to be the same. And all you do now is you go ahead and add. Another thing that sometimes people will think is, oh, I should reduce these fractions. I mean, after all, doesn't 2/18 reduce? Well, yeah, it reduces to 1/9, and that would just put you back to where you were a second ago. We have actually purposely unreduced these fractions because we needed those denominators to be the same. All you have to do to finish this thing off is add the tops, 15 plus 2, 17, and then keep the denominator the same. 15/18 plus 2/18 is 17/18. Now, before you put a box around this answer, now you would check to see if your final answer reduced, because you're always expected to simplify your final answer. Since 17 is prime, I don't have any common factors here, and I am finished. In the next video, we'll start dealing with these more complicated problems, but keep in mind that all of the concepts we just went through will be exactly the same.